Hi creators, this is Karthik. I'm currently doing my computer science and engineering in Sri Shairam Institute of Technology. I'm going to present a project which was done by me during our live in lab sections. So, actually, this project is mainly based on the deep learning. Let's have a look in this project. Yeah, come on. Let's come into the point. There's a fire detection using handcrafted features as a tedious task due to the time consuming method of features engineering. It is particularly challenging to detect a fire at an early stage in scenes with changing lighting condition, shadows, and fire-like objects. To overcome these issues, we investigate deep learning models for possible fire detection at early stages during surveillance. Taking into the consideration the accuracy, the embedded processing capabilities of smart cameras, and the number of false alarms, we examine various deep CNNs for the target problem. How? Let's have a look of proposed framework for the designing of fire prediction deep learning model. Yeah. So the cameras will act as an input sensors. These cameras will collect continuously the information, and the information will send continuously to the deep learning model with proposed YOLO v4 architecture. And the trained deep learning YOLO v4 architecture model will analyze and predict whether the frame contains fire or not. If the frame contains fire, then it sends an alert message to the owner or the security which is who are present in there. If it frame does not contains any fires, it will repeat its loop. So this is actual proposed framework of our project. Then we have a look at algorithm used in this project. So there are three types of algorithm has been used in this project. First of all, a future map selection algorithm for localization. However, the input images are given to the model. There is a future. That is, in our case, it's a fire. So the fire is identified and localized by using feature map selection algorithm and fire localization algorithm. Yeah, we identify the features we from the input, but we either identified feature whether it is a fire or not. For that, we need to analyze uh, the image using file localization algorithm. At last, a third and main important point in our project is an EOLO object tracking algorithm. It is a type of algorithm to track the real-time objects. Here, we are going to visualize the file location using EOLO object tracking algorithm. As I mentioned about the two different types of algorithm, such as a feature map selection algorithm and file location algorithm, uh, is important for our model. So these two features are combined to give us a YOLO object tracking algorithm. So let's have another look of architecture involved in this project. So CNN, it's a convolutional neural network. It is a basic image processing neural network architecture. The images are undergone several max pooling layers and valid padding layers, and at last it will changes into the flattened layers. These flattened layers are given as an input to the input layers of neural network, and the input networks input networks will continuously feed forward and backward in the hidden layers to get the accuracy of the fixed ground truth level. And then we have the look at YOLO v4 architecture. So YOLO v4 architecture is the main part of our project, and before that we watched about CNN architecture. So CNN architecture is the base or the backbone of the YOLO v4 architecture. So let's have a look. Let's have a look. So YOLO v4 architecture consists of a spatial pyramid crawling and a path aggregation network. So what does mean both of them mean? So SPP and PANS act as head and neck for the object tracking. CNN is used to process the image, like it's used to process the image, but SPP and PNN is used to visualize the object in that image. So this is a YOLO v4 architecture explanation. After that, here at last we are coming to the point. There's a transfer learning. By using YOLO v4, there have been detected pre-trained weights. They have been detected several objects using pre-trained weights. Here we are going to use the pre-trained weights, and just we are going to change the configuration of a file according to our customized need. Here in this case we are going to predict the fire, so it is a only single class prediction, and we need to configure as our customized needs. So transfer learning is very effective and fast way to begin with the problem, and it gives the direction to move. Most of the time best results are also obtained by the transfer learning. At last, here's the code flow. Install all the required libraries and collect required data sets and annotate the data set in the YOLO format. At last, that means fourth one, import YOLO v4 object tracking architecture to the code. And architecture, train the model using the annotated images. Customize the code to detect the fire. Yeah, I already mentioned there will be a code for an object tracking to find the number of objects. But here in our case, it is a single type class prediction. So we need to customize the code to our convenient needs. And then image frame processing up to 30 frames per second. That is, we can see the output with the 30 frames per second uh, in videos. After this, we can use an input to this model, and the model will display the output using the bounding boxes if the fire is present in the scene. At this is data sets have been collected for training the images. There's various type of data of fires, and these fires are get annotated using ImageSense.ai, and there is annotated here is samples of some annotated images, and these annotated images are in the format of YOLO because we are going to train with YOLO v4 architecture, so it is to be in the form of YOLO. So this is an annotated format. There is a series of the numbers. These numbers represent x, y, and coordinates of the file located, and the rows determines the number of fires in a single images. So this is an annotated format. And YOLO v4 custom configuration. So these configuration I already mentioned, we need to customize our code according to our need. So this is one of the part of the configuration that we need to do for running our model. So in this case we need to change the customized as single class, and then it is in data sets inflated in our Colab. So I have been used Colab for because it Colab provides a free and GPU, so I have been used that, and I have been inflated the data sets collected to the model. And the training part, it is a major part which has been done in our project. It takes around 3 hours to train my model. This is a training summary I have presented in front of you, and then we move on to the output part. So we are going at last, the input image given to the model will predict the output as a fire predictor. In the candle image you can see that it is a input image, and the output image is predicted with the candle bounding boxes. Bounding boxes, fire detected images. So fire detected images, these are the some of the fire images I just given to the model, and I tested that model, and these images get annotated as a fire, and which are the present in that images. It is also an image and image prediction. Let's say I have an video prediction, I just given a video to my model. These model get annotated, identify that video also. So continuously I just providing that also in front of you. At last, it's a live prediction which was done by me during the project. So I just going to run you. It's a video of my phone from the laptop. So I just light the matchbox. The matchbox, see, so the fire is get annotated when it's showing to the camera in a live time prediction. So this is my output prediction using our deep learning model.